So when you hear the name the Pirate Bay, your mind probably jumps straight to controversy, right? Well, for this explainer, we're going to set all that aside for a minute. We're going to look at it as a really fascinating piece of internet engineering. Because honestly, understanding how it works opens up this incredible and incredibly resilient world of decentralized networks.
All right, so here's our game plan. We're going to start with the basic problem that kicked this whole thing off. Then we'll break down what a torrent actually is, piece by piece. We'll figure out how all these users find each other, uncover what the Pirate Bay really does, and then wrap it all up by looking at the power of this whole decentralized idea.
Okay, let's dive right in. Before stuff like BitTorrent came along, the internet had this really simple but massive problem. You could say it was a problem of just digital physics and money.
Just think about it. Let's say you've got a huge file, a new Linux distribution, a giant scientific data set, whatever. How do you get that file to, say, 1 million people? If you just put it on a single server, you create a massive bottleneck.
And this right here shows the huge shift in thinking. The old model, on the left, is like one person with a garden hose trying to fill up 1,000 swimming pools. It's going to be slow, and that one person is paying for all that water. But the peer-to-peer model on the right, it's genius. It turns every single swimming pool into its own sprinkler. The more people who join to get water, the more sprinklers turn on, and the faster everyone's pool gets filled.
And that whole collaborative sprinkler idea? Well, it leads us straight to this brilliant solution, the peer-to-peer network. It just completely flips that old top-down model right on its head.
In a P2P network, every single computer is both a customer and a restaurant at the same time. The potluck analogy here is just perfect. Instead of one host getting totally overwhelmed cooking for 100 guests, everybody brings a dish, and the feast just gets bigger and better with every new person who walks through the door.
Now this is a really crucial point. BitTorrent isn't one website you go to or a single program you download. Think of it more like a language, a shared set of rules. It's the protocol that lets millions of computers all over the world organize their own little potluck dinners for sharing files super efficiently.
All right, so now that we get the big picture, let's really get into the weeds. How does this language actually work? What are the essential building blocks of a torrent?
This is the magic right here. Instead of downloading a giant file from start to finish, like a long piece of tape, your computer grabs thousands of tiny little pieces, and it grabs them in a totally random order from maybe dozens or even hundreds of different people at the same time. So while you're downloading piece number 57 from one person, you might be uploading piece number 12, which you just got, to somebody else. Now, this whole group of people sharing one specific file, we call that the swarm. And inside the swarm, you've got two main jobs. You've got leechers, who are still downloading pieces, but are also sharing the pieces they already have. And then you have the seeders. Seeders are the real heroes of the swarm. They've got 100% of the file, so they're just uploading, making sure that file stays alive and available for everyone else.
But wait a minute, how do you know that all these thousands of pieces coming from random strangers all over the world are actually correct and not messed up? Well, that's where something called hashing comes in. Every single piece gets a unique mathematical fingerprint. So when your computer receives a piece, it checks the fingerprint. If it's a match, great, you keep it. If not, you toss it and ask for it again. It's like a built-in, automatic quality control system that guarantees the final file is perfect. Okay, so we've got our swarm, they're ready to share all these verified pieces. But on an internet with billions of computers, how in the world does your computer find the right people in the right swarm to begin with? This is the discovery problem.
Well, the system had to evolve to survive. It started off with these things called centralized trackers. A tracker was basically a server that acted like a bouncer at a club. It kept a list of everyone in the swarm. The problem? It was a single point of failure. If you take down that one server, the whole swarm goes blind. And that vulnerability is exactly what forced the system to evolve into the completely decentralized model we have today.
And you can really see this evolution in the switch from old-school .torrent files to magnet links. See, a torrent file literally pointed to that one vulnerable central tracker. But a magnet link? It's just a hyperlink, a string of text. It doesn't point to any single server. It just contains the file's unique hash, that digital fingerprint we talked about. And your client uses that fingerprint to find the other peers directly.
So how does that even work without a central tracker? Well, the secret sauce is something called a distributed hash table, or DHT. The easiest way to think about it is that every single computer running a torrent client becomes one page in a massive, global, decentralized phone book.
So when you click a magnet link, your client doesn't call up a central operator. It just kind of shouts to its neighbors on the network, hey, anyone know who has the file with this fingerprint? And that question just gets passed from peer to peer to peer until it finds someone in the right swarm. It's brilliant.
Okay, so with all of that technical groundwork finally laid, we can tackle the big one. What is the Pirate Bay's actual and often misunderstood role in this whole ecosystem?
During their big trial in Sweden, their defense's main argument was that the site itself stores absolutely nothing. It's just a platform, a conduit. They argue that they don't hold any of the books, they just provide the library's card catalog that tells you where to find the books, which are stored in thousands of other places.
And in fact, the court documents are just full of these competing metaphors. Is it a search engine, kind of like Google? Is it just an old bulletin board where people post stuff? This whole conceptual battle was right at the heart of the legal case. Because, well, if you can't even define what something is, it becomes really, really hard to regulate it.
And this really gets to the core of the whole debate. The central question was this: is providing a map the same crime as actually driving the getaway car? You see, the law was built for a world of physical things, and it really struggled to apply old ideas like distribution to this new world of decentralized information.
So let's just be crystal clear on this, because it's the most important point. The Pirate Bay does not and never has hosted a single byte of the actual content. It is simply a searchable database of magnet links. It's a giant, user-generated phone book that helps people in a swarm find each other. That's it.
All right, let's pull all of these threads together and see why this kind of architecture is so incredibly hard to shut down.
And here it is. This might be the single most staggering fact in this whole story. Because the site is just a list of text links, a full backup of the entire Pirate Bay database is tiny. We're talking around 100 megabytes. To put that in perspective, that's smaller than a handful of high-quality photos on your phone. You could fit the entire phone book for the world's biggest file-sharing index on a cheap little USB stick.
And that's the ultimate takeaway. The system's greatest strength is its complete lack of a center. By switching to magnet links and that DHT phone book system, BitTorrent got rid of its single point of failure. And because the index itself is so ridiculously small, if one version of the Pirate Bay gets taken down, hundreds of mirror copies can pop up almost instantly. There is no single head of the Hydra to cut off.
And that leaves us with a final thought to chew on. This core idea, resilience through decentralization, which was really pioneered by these early file-sharing networks, is now the bedrock of so much of our modern internet. The principles that make the distributed hash table work, for instance, are a direct ancestor to the technology that makes cryptocurrencies like Bitcoin even possible. That unstoppable architecture of the swarm, well, it turns out it's everywhere you look.